So in today's video, we're going to take a look at the derivatives of hyperbolic trigonometric functions. And if you've never been exposed to these functions before, they're essentially just different combinations of e to the x and e to the negative x. So sine hyperbolic of x is given by 1/2 e to the x minus 1/2 e to the negative x. And we denote hyperbolic by this like h over here right next to the sign. And then cosine hyperbolic is just going to be 1/2 e to the x plus 1/2 e to the negative x. And then if you wanted to find the other hyperbolic trig functions like tangent and cotangent, then you would just take different ratios of sine and cosine hyperbolic according to the actual trig functions. So let's actually go ahead and take the derivatives of these functions now. And so sine hyperbolic's derivative, the first thing we can do is just rewrite sine hyperbolic in terms of, e to the x. That's going to be derivative with respect to x of 1/2 e to the x minus 1/2 e to the negative x. And we know that the derivative of e to the x is just itself. And so the derivative of 1/2 e to the x is just going to be, again, itself. It's going to be 1/2 e to the x. And then over here, e to the negative x. This is kind of a composite function. We're kind of inputting negative x into e to the x. And so the derivative is going to be, first of all, it's going to be the derivative of e to the x, right? Which would just be itself. And then it's going to be multiplied by the derivative of -1, or of negative x, which is just -1. And then here we already have a negative sign, so it's going to be plus 1/2 e to the, and then we have to input negative x into our derivative, so e to the negative x. Let me remove that over there. And so over here, you're going to notice that this is essentially just cosine hyperbolic. So this is equal to cosine hyperbolic of x, and so we already have a very nice relation that the derivative of sine hyperbolic is cosine hyperbolic. And then if you go through the same process, you'll actually come to find that the derivative of cosine hyperbolic is actually just sine hyperbolic. And so again, we have another very nice relation over there. And so it's a little bit different from the basic trig functions. In fact, I'd say that this is a little bit easier because you don't even have to think about a negative sign. You just get derivative of sine hyperbolic, cosine hyperbolic, and then cosine hyperbolic is sine hyperbolic. So you're kind of just like, I would say, sort of alternating or oscillating between these two. And I encourage you to actually take the derivative of cosine hyperbolic yourself to actually prove it. And then for tangent hyperbolic, we can rewrite this as the ratio of sine to cosine hyperbolic. So it's going to be sine hyperbolic of x over cosine hyperbolic of x. And then we can use the quotient rule here. So we know that the derivative of sine hyperbolic is cosine hyperbolic, or multiplying that by the denominator. So we will end up with cosine hyperbolic squared of x. And then we're going to go ahead and subtract. We're going to subtract the numerator, which is sine hyperbolic, times the derivative of the denominator. So we're going to end up with sine hyperbolic squared of x. And then again, we're just going to divide that by the denominator squared. So it's going to be cosine hyperbolic squared. And there's an identity here, which if you take hyperbolic geometry or just a very introductory course on these hyperbolic trig functions, then you'll come to find that this right over here actually simplifies to 1, because we can maybe delve into these hyperbolic trig functions a bit later, but for now just accept this identity and try to prove it for yourself. Actually, it's quite nice and easy. So this is going to be equal to 1 over cosine hyperbolic squared of x, which is just, 1 over cosine squared of x, we said, was secant squared of x. And so the same thing holds true for hyperbolic cosine. So we're going to end up with, I don't know what's going on, secant hyperbolic squared of x. And so that would be our derivative right over there. Okay, I don't know what's happening right now. And then if you go through the same process for hyperbolic cotangent, then you will end up with negative cosecant hyperbolic squared of x. And I encourage you to actually try this one out for yourself just to get more practice taking the derivatives of rational functions. And then same thing for secant, hyperbolic, and cosecant. I'm not going to go through these proofs, but I encourage you to try them yourself. And if you do go through with it, you should end up with negative secant hyperbolic, tangent hyperbolic, as the derivative of secant hyperbolic of x. And then for cosecant, it will be negative cosecant times cotangent hyperbolic of x. So that would be the derivative right over there. And we have a very nice symmetry when it comes to these hyperbolic trig functions and their derivatives. And they're very important when we're going to start delving into differential equations, as we'll come to find that many of these solutions to these differential equations can be expressed in terms of these hyperbolic trig functions.